All right. Hey guys. Welcome back. I pre-recorded this week's lessons as well, just so that you guys could watch them as many times as you needed to, as well as rewind, pause, whatever you need to do to help you understand the lesson. So what I want to do is I want to go over the schedule with you first of all, so that you know what to do and when. This week, make sure I'm on the right page. This week, Monday, lesson 7 in Zern. Tuesday is a makeup day. If you have not submitted science to me, I need it by the end of the week. If you do not have it submitted by Sunday at midnight, then you will not be receiving credit for it. I'm giving you time to make up the assignment, so I really hope that you take that time to do so. Um, Wednesday is lesson 8 in CERN. Thursday is another makeup day, so that's another day to catch up on science if you're behind. And then Friday is lesson 9. All of your work is due to me Sunday by midnight in order to receive credit. I did go ahead and include the lesson 19 and 20 from next week on here because once we do the 3 lessons this week, we have 2 the following week, and then we're done with math for the year. So I wanted to go ahead and get all of the lessons knocked out. That way you guys had them. If you would like to go ahead and complete 19 and 20 this week because you don't feel like doing it next week, then you need to shoot me a message as soon as you finish lesson 9, and I will go ahead and bump you up to where you need to be on Zone. It's not going to skip for you, so I will have to move you up, so make sure you send me a message. The following week, the schedule is a little bit different. You guys have some activities that I would like you to do. So the following Monday, and let me go ahead and check my calendar so I can give you an exact date. I want to say it is May 11th. It is. So May 11th, Monday's assignment will be list any concepts you want to review. So anything in math that you found difficult. If you found adding fractions difficult, that would be something you would get your parent, or you could even send it to me and let me know, hey, I didn't really understand this. Can you please review it? Tuesday, you'll do lesson 19 on Zern. Wednesday, I want you to record a video or write a letter about your favorite and least favorite parts of the school year. Video would be preferred so I can see you guys because I miss you a whole lot. But if you don't have that option, please write it out on paper. Take a picture, send it to me. You could write an email if you have an email and email it to me, whatever works best for you. But I want to hear about your favorite and least favorite parts of the year. Thursday, you'll do lesson 20 on Zern, and then Friday will be your final makeup day before the last week of school, last week of 5th grade for you guys. It's a big deal. You guys are going to middle school next year. I'm so excited for y'all. All right, so we are going to jump into the lessons. This week we're doing lesson 7 first, so I'm going to screen share with you guys. Okay, and you can see my screen. Let me go ahead and log back in. All right, curriculum, we are grade 5. We're on module 6, and we're going to be doing lessons 7, 8, and 9 this week, and then 19 and 20 next week. So lesson 7, I'm going to go ahead and go over the standards with you. Lesson 7, students will plot points, use them to draw lines in the plane, and describe patterns within the coordinate pairs. Lesson 8, students will generate a number pattern from a given rule and plot the points. Lesson 9, students will generate 2 number patterns from given rules, plot the points, and analyze the patterns. The following week, your standards are students will plot data on line graphs and analyze trends, and students will use the coordinate systems to solve real-world problems. So we are going to start off with lesson 7. That's the point.
Hey there, Zerner. Let's get started. Plot these points on the coordinate plane.
Okay. And I'm really glad they started off with this because I got a lot of messages last week about I don't really understand how to plot points. How did you know that it was a fraction? How did you know it was that specific fraction? So, what I want to do is I want to talk about that really quick. Now, in this coordinate plane that we've got right here, it starts at 0 and it goes all the way to 5. Remember, I told you whatever it does on the x-axis, it's also going to do on the y-axis. So if it goes to 5 on the x-axis, it's going to go to 5 on the y-axis, okay? The next thing I need to look at is I need to look at my lines that are going up and down, okay? I see that my first line is not a whole number. That means that it has to be a fraction. If it is not a whole, it will be a fraction. Now, because I only have one line and it's halfway between 0 and halfway between, well, 0 and 1, then that means that my fraction is going to be 1/2. So if I was going to label this whole number line, I would have 1/2, 1, 1 and 1/2, 2, 2 and 1/2, 3, 3 and 1/2, 4, 4 and 1/2, and then 5. And it would continue all the way down if this coordinate plane was longer, but it's not. Okay, so please keep in mind that this would be a half because it's halfway between 0 and 1. Okay, now if you were to see multiple lines before you got to that 1, you could number them. Like, let's say we had a line here and a line here. That would be 1, 2, 3, and then this would be line number 4. That means that your whole would be 4/4. Then you would have 3/4, 2/4, 1/4. Now you know that this is a half, and 2/4 is an equivalent fraction to 1/2. Okay, we don't see those lines here. That's just an example, but I want you to try to do your best to understand what fractions are being used and why. Okay, so what it's asking us to do is it's saying plot points A, B, C, and D on the coordinate plane. So we see that A is at 0 on the x-axis, 0 on the y-axis, and the points are 0, 0. So I'm going to go to 0 because I always start with the x-axis first, and I'm going to go up 0. That means that my first point is starting at the origin of my coordinate plane, okay? Then I have point B, 1, 1. I'm going to go over 1 and up 1. Then I have 2, 2. I'm going to go over to 2 and I'm going to go up 2. Then I have 3, 3. I'm going to go over 3 and up 3. Always go over before you go up. You always, always, always start with the x-axis first. Okay?
Here is point A, point B, point C, and point D. I'll draw a line through the points like this. Take a look at all the points on this line. Did you notice a pattern in these coordinates?
Okay, and I'm going to pause her really quick. What I want you to look at is when she drew her line connecting her points A, B, C, and D, notice that it has the little arrow at the end. When you are drawing this out, let's say you get to 6th grade, and this is what you guys might start with. I'm really not sure, but let's just say this is what you start with. If your teacher next year says that you need to connect the points with a line, make sure you put the arrow at the end. That shows that it is a continuous line, okay? Don't just draw a line with no arrow at the end. It has to have this arrow. You want to show that it's a continuous line.
The x-coordinate is the same as its corresponding y-coordinate. They're always equal to one another. When x is 0, so is y. When x is 1, so is y, all the way up to 3, 3. Will the point with coordinates 4, 4 also fall on this line?
Okay? So it says, will the point with coordinates 4, 4 fall on this line? So if we think about our points, we have 0, 0, 1, 1, 2, 2, 3, 3. If I was to go over here and go to 4 and go up to 4, does it fall on that line? Well, yes, it does. You can see that if I plotted it, it would fall right here and it would touch our line. So the answer would be yes.
Yes, the point with coordinates 4, 4 will fall on the line.
That's right. We can plot it right here on the same line. As long as the x and y coordinates are the same, the point will be on this line. We can describe the relationship between these coordinates with the rule x and y are equal. We can also say the rule y is equal to x. Will the point with coordinates 10, 10 fall on this line? Think about the rule to help.
Okay, so our rule was x and y are equal. So it's saying, will 10 comma 10 fall on this line? Well, if x is 10 and y is 10, that means that our values are equal. So yes, 10 comma 10 will fall on this line.
Yes. We can't see 10, 10 on this coordinate plane, but the x and y coordinates are equal. So the point 10, 10 will be on this line.
Exactly. Now, write a coordinate pair for a point on this line that has mixed number coordinates.
All right, so for this one, there can be multiple answers. It doesn't have to be the same as mine. It might be easier to use my answer. That's okay if you do that. Try your best to use something different. I want to see what you guys can come up with on this. So what it's asking us to do is it's asking us to write a coordinate pair on this line with mixed number coordinates. So that means I need to go to my line, and I can trace my line up. And I know that if it's not a whole number, it's going to be a fraction. So that means my very first line right here on my coordinate plane is going to be a fraction. If it's halfway between 0 and 1, then it's going to be 1/2. So I can write my very first, let's see, it wants a mixed number, so I can't use 1/2. Let's keep going up a little bit. Let's use 1 and 1/2. Okay, so I'm going to type in 1 and 1/2. Okay, and then if I'm at 1 and 1/2 on my x-axis, I'm also at 1 and 1/2 on my y-axis. Remember, x and y are equal. That was our rule.
Here are some examples of coordinate pairs with mixed numbers.
Notice
that
their
are on
x
this
and y
line.
are equal as well here.
As long as the x-coordinate and y-coordinate are equal, the point will be on this line. Now, write a coordinate pair for a point that will not fall on this line.
Okay, and this is what I was thinking about when I was talking about the 1/2. So we're going to use 1/2 here. Okay, it says that is not on this line. So I'm going to use 1/2. Okay, here's my 1/2, or my half. Sorry, I'm going to use it for my x, and then I'm going to go up to a point that's not on the line. So I could go way up here to 2. And I know that that's not going to fall on my line. So 1/2 and 2 will not touch this line. You can use any point. So let's just say you wanted to go way over here and use 3 and 1/2. You could say 3 and 1/2 and 2, 3 and 1/2 and 1. You could say 4 and 1/2 and go up to 4. You could say 4 and 2. You have a lot of options, okay? So make sure to use some different ones.
Here are some examples of coordinate pairs that will not fall on this line. X and Y are not equal. Great work so far, Zerner. Let's keep.
All right, I'm going to fast forward her, okay? So for each point is x equal to y. So let's look at our first one at point G. We have x is 0, y is 3. Well, I know that 0 is not equal to 3. So let's look at H just to double check before we finally decide on an answer. H says x is 1/2, y is 3 and 1/2. Well, 1/2 is a lot smaller than 3 and 1/2. So that means that our points are not equal. Okay, it says for each point, which coordinate is greater? So if I'm looking at my x coordinate, I have 0, 1/2, 1, and 1 and 1/2. If I'm looking at my y coordinates, I have 3, 3 and 1/2, 4, 4 and 1/2. It's asking which coordinate is greater, x or y. Well, in point G, I know that 3 is greater than 0. So that means the y coordinate is greater than the x coordinate. How much greater is the y coordinate 3 than the corresponding x coordinate 0? Well, if you think about it, what plus 0 equals 3? That would be 3. So 3 is 3 more than 0. 3 and 1/2 is blank more than 1/2. Well, what would I have to add to 1/2 to get 3 and 1/2? The answer would be 3 again. 4 is how many more than 1? What plus 1 would give me 4? 3. 4 and 1/2 is blank more than 1 and 1/2. Well, what plus 1 and 1/2 would give me 4 and 1/2? The answer is 3. Okay, I'm going to fast forward her just a little bit. So it wants us to plot points G, H, I, and J on the coordinate plane. So I know you don't have your zone books, and that's perfectly okay, but I'm going to try to mark it with my mouse. So for point G, I'm at 0, 3. So that means I'm going to start at 0. I can't go over because it's 0, so my mouse isn't going to move, but I have to go up 3. So my very first point, point G, would be right here on my coordinate plane. H, I'm going to start back at the origin. I'm going to go over to 1/2, and I'm going to go up 3 1/2. So my next point would be here. Point I would be over to the 1 and up 4. So my third point would be here. And then J says 1 and 1/2 and 4 and 1/2. So I'm going to go over to 1 and 1/2, and I'm going to go up to 4 and 1/2, and that would be my final point. Okay, gonna fast forward. So they went ahead and drew it out because we don't have our notes. So look at G, H, I, and J. I already know that if I could draw a line here and connect all of these points with my little arrow at the end to represent a continuous line, I can do the same thing here. So what they're going to do is they're going to draw a line through with an arrow at the end to represent this continuous line. Okay, and there they go. You can see the arrow on both ends. That means it's a continuous line. We haven't gotten to multiple quadrants in a coordinate plane. They're just giving you the one quadrant for now. So this could actually extend into this other side in this quadrant, which is why they have an arrow right there. Okay. So if x is 2, what is y? Write the coordinate for point K, then plot point K on the coordinate plane. Okay. So in each of these, if we rewind back to the previous little dots that we clicked on, it asks us if I had point 0 for x and I have point 3 for y, how many did I need to get to 3? Well, I told you 0 plus 3 is 3. So if I added all of these by 3 to get the y coordinate, I'm going to add 2 plus 3 to give me 5. So that means point K would be 2, 5. Okay? And then they plotted it for you. So you go over 2 and you go up 5, and there's point K. Okay? I'm going to speed it up. Okay, it wants to show you the rule.
Let's keep it going, Zerner.
Sorry, I think I might have clicked too far. All right, so it says plot the points on the coordinate plane. I have x is 1 and y is 1/2. So I'm going to go over 1 and then up 1/2 because it's halfway between 0 and 1. Okay. Plot number 2, point number 2 says I need to go over 2 and up to 1 1/2. Then I have 3 and I'm going up to 2 1/2. And I plotted my points. Okay. It says write a rule to describe the relationship between the x coordinate and y coordinate for any point on this line. Use only the tiles you need. All of the tiles will not be used, guys. So we have to be careful about what we put for our rule. What I want you to do is I want you to look closely. We have 1 and our y point was 1/2. Well, that means that the y coordinate is 1/2 less than the x coordinate. So I could say that y is 1/2 less than x. Okay. That's just saying on all of these that if I took my x coordinate and I subtracted a half, I'm going to get my y coordinate. So 3 minus 1/2 is 2 and 1/2. Okay. Write a rule to describe the relationship between the, ooh, sorry guys, the lights went out on me. Write a rule to describe the relationship between the x coordinate and y coordinate for any point on this line. Use only the tiles you need. So let's look at these points. These are the same ones. And I think we just did this. So y is 1/2 less than x. Maybe I didn't click the right button. I did.
Any point on this line follows the rule y is 1/2 less than x. 3 is 1/2 less than 3 and 1/2. So we know this point is on the line. 10 and 1/2 is 1/2 less than 11. We can't see it on this coordinate plane, but it follows the rule. So we know this point is on the line.
Okay, I'm going to pause her because I think I missed something along the way that you guys will have to do. So what it's going to do is it's going to give you these 4 points. It's going to give you 3 and 1/2, comma 3, 11, comma 10 and a half, 3, comma 3 and a half, and 11, comma 10. And it's going to say if the rule is y is 1/2 less than x, which of these would fall on our line that we graphed, and which of these would not fall on the line. Well, if the rule says y is 1/2 less than x, that means that you're going to get a smaller number as your y point, okay? It's also going to have to be a half less. If I look at this point right here, 11, comma 10, if I take 11 and I subtract a half, I should get 10 and 1/2. This says that I get 10, so that means this would not be on the line. If I took 3 and subtracted 1/2, I should get 2 and 1/2. Well, this says that it would be 3 and 1/2, which means we went up a half. If we're talking about less than, that means that this point would not be on the line. These 2 points are on the line because if I take 3 and a half and subtract my half, I'm going to get 3. If I take 11 and I subtract my half, I'm going to get 10 and a half. Just wanted to explain that for you guys.
These points are not on the line because they don't follow our rule. 3 and 1/2 is 1/2 more than 3. So this doesn't follow the rule that the y coordinate is 1/2 less than the x coordinate. And 10 is 1 less than 11, which also doesn't follow our rule. Great work today writing rules for points on the same line.
All right, I'm going to go ahead and pause her and then go back. So the next thing you need to do is the Tower of Power. I have had several of you guys say that on the videos I don't have the Tower of Power, and you are correct because we know that when we do the Tower of Power, there are a bunch of different forms that it gives us. Not everybody's is the same. So it would be hard for me to do the Tower of Power and only give some of you the answers and show you the answers, and others would not be getting the same question. So I'm not going to do the Tower of Power with you. I'm just going to do the math chats. And I hope the math chats that I'm doing with you help in some way. All right, so lesson 8, we're moving on and we're plotting the rule.
Hi, Zerner. Today, we're going to work with the coordinate plane. I have some rules that describe the relationship between the x and y coordinates for points on a line. But I only know the rule and the x coordinate. Can you help me crack the code and find each y coordinate? Let's warm up with this rule. Y is 1 more than x.
All right. So complete the table. For each x coordinate, what is corresponding y coordinate? Rule, y is 1 more than x. Well, if I'm talking about 1 more, I know that the more, when we were talking about key terms right before we were going to LEAP test, more meant addition. So all I'm going to do is I'm going to take my x coordinate and I'm going to add 1 more. So 0 plus 1 is 1. 3 plus 1 is 4. 10 and a half plus 1 is 11 and a half. Okay, all we did was add 1 more. And then it just wants you to write your coordinates in the correct format. So you know you have to put x, comma, y, x, comma, y, x, comma, y.
Y is 1 more than x. So the y coordinate's value is 1 more than the x coordinate's value in any given coordinate pair. Let's try this rule. Y is 5 times x. For each x coordinate, what is the corresponding y coordinate?
All right, so our rule is 5 times x. That means I'm going to take whatever my x point is, and I'm going to multiply it by 5. So 0 times 5 is 0. 1/2 times 5 is 2.5. In decimal form, we will write that 2.5. And then 1 times 5 is 5. So then I'm going to write it out in my correct format. X, comma, y. X, comma, y. X, comma, y.
Great warm-up, Zerner. Let's dive in with some new rules. This time, we'll find each y coordinate, write the coordinate pairs, and then plot the points. Let's try y is 1 more than 3 times x.
All right, so these are getting a little bit harder, but that's okay. You guys can do it. I believe in you. What it's asking us to do is it is saying that y is 1 more, which means we're adding 1, than 3 times x. So what it's asking you to do is if you set this up as a problem, you're going to say 3 times x plus 1. So you plug whatever number you see for x into x in your problem. So you would say 3 times 0 is 0, and 0 plus 1 is 1. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 more is 10. Then you write it out in the correct format. So x comma y, x comma y, x comma y. All right, then we're going to plot them. So I see that I have 0 comma 1. I'm going to start at 0 and I'm going to go up 1. I'm going to go over 2, up 7. I'm going to go over 3, up 10.
Let's draw a line through these points like this. Even though we only have
Notice
3
that
points
arrow,
plotted,
continuous
there
line.
are a lot more points that fall on this line. Think about this rule carefully. What is another point that would fall on this line?
Okay, so they're asking us to come up with our own point that would fall on this line. There's multiple answers, but the one that looks easiest for me that I can go ahead and see is I'm going to plug in the number 4. Okay, if my line is continuous, that means it's going to keep on going. I'm going to plug in 4 and continue with my x all the way down. And I'm going to say 3 times 4 equals 12. Well, 12 plus 1 more is 13. So my x was 4 and my y is 13. If this coordinate, this little quadrant kept going and we had like, it was up to 15 instead of 10, you would be able to plot that point. Okay. So it says the rule is 1 less than 2 times x. So I'm going to take whatever my x is and I'm going to multiply it by 2 and then I'm going to subtract 1 because less means subtraction. So I have 2 times 2 is 4. 4 minus 1 is 3. 2.5 times 2 is 5. 5 take away 1 is 4. 2 times 3 is 6. 6 take away 1 is 5. Then I'm going to write them in the correct form. I already told you x comma y. And then I'm going to plot them on my graph. So I'm going to go over 2, up 3. I'm going to go to 2.5, up to 4. And I'm going to go over 3, up 5. Now it says, which picture shows the line drawn correctly through all of the points? You could draw a straight line through these points, which would make this answer incorrect. Your continuous line has to touch all of your points. So that means this would be the correct answer. All right, now name a point that falls on this line. Name a point where the y-coordinate is greater than 10. Okay, so let's say that I'm just going to use 6. 6 is random. So if x was 6, that means 2 times 6 is 12, and 12 take away 1 is 11. So that means my x would be 6, and my y would be 11.
Let's wrap up with some different codes to crack. Take a look at these tables. Which rule describes the coordinates in each table?
All right. It says match the table with the rule that describes its coordinate. So look at our very first table, okay? I see 2, and then if I figured out what times or plus 2 would get me to 4, I could say 2 plus 2 is 4, and 2 times 2 is 4, okay? So that one would be hard because more than means addition and times is multiplication. So let's try it on the next one just to double check before I click an answer. So I have 3.5 plus 2 would not give me 7. It would give me 5.5. So that means for this one we have y is 2 times x. 4 times 2 is also 8, okay? Then we have this one right here. We have 0 and we're going to 2, 5 we're going to 2, 7.5 we are going to 9.5. It looks like we are adding 2 each time. Well, here it says y is 1 more than double x. So if we doubled x, that would still be 1. Well, no, it would be 2. Sorry, my bad, guys. If we doubled x, 1 times 2 is 2, and then 2 plus 1 is 3. 3 times 2 would be 6. 6 plus 1 would be 7. 4.5 times 2 would be 9. 9 plus 1 is 10. All right. And that is lesson 8. You do have to be a little bit careful with those rules because they can sound one way, and then when you write them out and actually look at them on paper, they are completely different. All right, moving into lesson 9. This is the last lesson for this week. And we're going to be using patterns on a coordinate plane. So it says, what is the y-coordinate when x is 1? Well, if our rule says y is 2 more than x, 2 more means I'm adding 2. So 1 plus 2 is 3. Okay. Complete the table. For each x-coordinate, what is the corresponding y-coordinate? Rule. Y is 2 more than x. Well, 2 more means I'm adding 2. Well, they already did 0.1 for me. 1 plus 2 is 3. 2 plus 2 is 4. 4 plus 2 is 6. And 6 plus 2 is 8. Okay, then I'm going to write them in their correct form, x comma y. Remember, x always comes first.
These points.
And I'm going to fast forward through here so I can talk to you guys about the lesson. So it says plot these points on the coordinate plane. Okay, so I'm going to start and I'm going to go over 1, up 3. I'm going to go over 2, up 4. I'm going to go over 4, up 6. And I'm going to go over 6, up 8. Now, what I want to explain to you really quick is you might have not understood that this line right here was 1 because it's not labeled. It can't be a half because the half is not between 0 and 2. It's between 0 and 1. So this is asking what is halfway between 0 and 2. Well, that means that 1 would be halfway between 0 and 2. That is why I use this as 1. So it's just like a regular graph. They just didn't put 1, 3, 5, 7, and 9.
I'll plot.
Okay. Complete the table. For each x coordinate, what is the corresponding y coordinate? Y is 4 more than x. 4 more means I'm adding 4. Be careful and make sure you do not multiply, okay? It can mess you up. So y is 4 more than x. Well, 0 plus 4 is 4. 2 plus 4 is 6. 4 plus 4 is 8. And 6 plus 4 is 10. I'm going to write them in their correct format, x comma y. And I'm going to submit. All right, it says plot the points for line G. So I'm going to go 0 up 4, over 2 up 6, over 4 up 8, over 6 up 10, and that will give me my line. Okay, it says complete the sentence. Line F and line G are blank. We have two words. We have perpendicular and we have parallel. I taught you guys about parallel lines when we were doing shapes. You know that parallel lines kind of look like a railroad track. So if I was to draw the little lines between this, it would definitely look like a railroad track. So that means that these lines are parallel lines. I know that they're not straight up and down, but they don't have to be. They can be sideways as long as they are still side by side and they do not intersect. Okay, so it says, how are line F and line G different? It says line F is higher on the coordinate plane than line G. Well, we know that's not true because G is on top of F. So that means that line G is higher on the coordinate plane than line F. Okay. Will line H be parallel to line F and line G, or will it intersect? Okay, so line H's rule says 7 more. All right, well, if we go look at line F's rule, it was 2 more. So here's line F. Line G's rule is 4 more. Well, adding 4 is definitely going to be bigger, so that means it's going to be higher up. If I look at 4 compared to 7, 7 is definitely going to be more. So that means line H would be somewhere up here, which means it would fall on top of line G. So it will be parallel. It will not intersect. Okay. Then it says line H will be higher than both line F and G. Complete the table. For each x coordinate, what is the corresponding y coordinate? Well, we know that 7 more means I'm adding 7. So 0 plus 7 is 7, 1 plus 7 is 8, and 3 plus 7 is 10. I'm going to write them in the correct format, which is x comma y. And then it wants me to plot them on the graph. So I start at 0 for x, and I go up 7, over 1, up 8, over 3, up 10. And now I've got line H. Okay. I'm going to skip through the notes because you guys don't have these. I'm so sorry I didn't get you guys your own books. I'm going to try to move through this so we can actually do a problem together. All right, so how are the rules for line P and line Q different? Line P is 2 times x, and line Q is 3 times x. Well, I know, let's just say that y is 1, or x is 1. 2 times 1 is 2, so y would be 2. 3 times 1 would be 3, so y would be 3. Well, that obviously means that y for Q is going to be larger, because if you multiply something 3 times, it's going to definitely be larger than 2 times. So that means that line P's rule doubles the x coordinate, while line Q's rule triples the coordinate. So think about how steep this line will be. Steep means, let's pretend that you were on your bicycle and your bicycle was going to start at the top of the line and go all the way down. Think about it like a really big hill in your neighborhood, or a really big hill you've ever driven down in a car, okay? If my car or my bicycle was up here and it was going down this line, compared to starting up here and going down this line, think about the bigger chance of you flipping over on your bicycle or maybe falling off your bicycle. That's when we're talking about steepness, okay? The possibility of you going at such an angle that you're going to fall over. So that definitely means that the steepest line would be line R. That is not something I would want to ride my bike down for sure. Okay. So it says, consider the rules of line R, line Q, and line P. What can we predict about line U? Well, it says line U, rule y is 1/3 as much as x. Well, if I look at my values for line R, I have 5 times, line Q is 3 times, and line P is 2 times. I'm going from whole numbers to a fraction. If you think back in time to when we were working with fractions, you know that a fraction is much smaller than a whole number. So that means that line U is not as steep as line P. Line U will be spaced out a little bit better. It'll be easier to ride your bike down for sure. Okay, so it says complete the table. For each x coordinate, what is the corresponding y coordinate? Y is 1/3 as much as x. This is rewinding time to when we multiplied a whole number by a fraction. So 3 times 1/3, that gives me 3 times 1, which is 3, over 3. Well, 3/3 is 1 whole. Basically, all I'm doing is I'm dividing by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 3. I'm going to write them in their correct format, x comma y. And that completes my problem after I plot them on the coordinate grid. So I'm going to go over 3, up 1, over 6, up 2, and over 9, up 3. And that shows you that is definitely something I would ride my bike down compared to over here on line R. This looks like I'm about to just straight fall, and this one looks like I'm just coasting down a nice hill.
These points are on line U. Lines P, Q, and R got steeper and steeper because we multiplied x by a greater factor. In line U, we multiplied each x coordinate by 1/3, which is
So that means the greater the factor that you're multiplying by, the steeper the line. So the bigger we got, we had 5 times, the steeper the line. 3 times, little less steeper. 2 times, less steeper than Q. And then when we got down to a fraction, that's definitely less than 5. It was it was not as steep at all.
less than 1 to find the y coordinates. So line U is the least steep of the 3 lines. Nice work, sir.
All right, so that is lesson 9. We are coasting right along with the coordinate systems. And I'm going to go ahead and move into next week's lessons. If you would like to go ahead and do them this week and get them over with so that you are done and caught up, I do not mind. I know that it's not going to move you, so please email me and ask me to move you up instead of completing all the lessons between lesson 9 and 19. That's a lot of lessons, guys. So please shoot me a message if you'd like to start them early. If not, you can wait until the following Monday, and I will go ahead and move you up as soon as the submission time is up. So lesson 19, we're plotting more data on a grid. So I'm going to go ahead and move to it. It says we are plotting Cammie's weight at each 4-month period on the line graph. All right. So when Cammie was 0, and you can see that your graph is labeled, okay? You've got age in months at the bottom, and you've got weight in pounds on the side. So that means that our x-axis represents age, and our y-axis represents weight. They also titled it. So if you were ever to draw out your own line graph and in your grid, then you would have to give it a title, okay? So they named this Cammie's weight. So we see that when Cammie was 0 months old, she weighed 5 pounds. So that doesn't mean that she was 0 months. That means right when she was born, okay? She was 5 pounds. Well, when she turned 4, remember I'm working in age, 4 years old, she weighed 20 pounds. When she was 8 years old, she weighed 30 pounds. When she was 12 years old, she weighed 40 pounds. 16 years old, she weighed 45 pounds. 20 years old, she weighed 50. 24 years old, she weighed 50. And 28 years old, she weighed 50.
At 0 months, Cammie weighed 5 pounds. At 4 months, she weighed 20 pounds. At 8 months, she weighed 30 pounds.
Okay, and they're just going to graph it all the way across, which is fine. It's exactly what we did. So you can obviously see that when she was first born, her weight began to increase. Okay, that's normal. Most dogs are born kind of small and then they grow to be super, super big. I can say that because I have a German Shepherd. When she was a puppy, she was teeny-tiny. She wasn't the smallest dog, but she also wasn't huge. Okay, now she's about 70 pounds. She's a big girl. So versus when she started, when she was first born to now, her weight increased just like Cammie's. So if I had to plot her weight on a graph, her line would also go up and then it would kind of stay the same, which is what we saw here when she was 20 months to 28 months. She weighed 50 pounds and it never changed. That's not a bad thing that her weight didn't change. It just stayed constant. The word is constant, okay? It did not change. So it says, what is true about Cammie's growth over time? Well, I know that Cammie gained weight until she was 20 months old, then she stopped gaining more weight. Okay, we can see where she gained the weight. And then when she got to about 20 months old, she didn't gain or lose anything. She just kind of remained the same. She had a constant weight of 50. Okay, it says, how much weight did Cammie gain in the first 4 months of her life? Well, Cammie went from 5 pounds to 20 pounds. So what plus 5 would give me 20? Well, that means that she gained 15 pounds in the first 4 months of her life.
Cammie weighed 5 pounds at 0 months.
Okay, and he's just going to repeat what I said. So it says, how much weight did Cammie gain in the second 4 months? Well, we started at 20 and we went up to 30. So what plus 20 would give me 30? Well, 5, 10. So that means she gained 10 pounds in the second 4 months. All right. Now it says, how much weight did Cammie gain more weight in the first 4 months or the second 4 months of her life? So if we're looking from when she was born to the first 4 months, she gained 15 pounds. If we're looking from the second 4 months, that would be from 4 to 8, she only gained 10 pounds. So that means Cammie gained more pounds in the first 4 months of her life. 15 is greater than 10. And we're talking about the first months when we're talking about 15. Okay. It says, how much more weight did Cammie gain in the first 4 months than in the second 4 months? Well, we know that all we have to do to find the difference between the two weights is subtract. Difference means subtract. So I have 15 take away 10, which is 5. What happened to Cammie's weight between the ages of 20 months and 28 months? That's this point right here where everything stays constant. So that means that Cammie's weight stayed the same. All right, now we're moving on to our next question. It says, plot the rainfall at each half-hour increment on the line graph. So half hour, when we're talking about time, is 30 minutes. You can see it over here. They gave you your times and they gave you your rainfall, okay? And you can see that it's in 30-minute increments. So 2 to 2:30, 2:30 to 3, 3 to 3:30, 4 to 4:30, 5 to 5:30, and 5:30 to 6, okay? And we're just going to graph those. So at 2 p.m., there was no rain, okay? At 2:30, that's the point between 2 and 3. At 2:30, there was 1/4. Now, this is one of those where you had to know the fraction. So I had 1, 2, 3, 4 lines until I got to a whole. That means my whole would be 4/4. So my line here would be 3/4, 2/4, and 1/4. That's how you're getting that fraction of a fourth, okay? At 3 o'clock, we're going to have 3/4. At 3:30, we're going to have 1. 4 o'clock, we're going to have 1. 4:30, we're going to have 1. 5, we're going to have 1 3/4. That's that line right before you get to 2, okay? 5:30, we're going to have 2. 6 o'clock, we're going to have 2 1/4. And then that's our last point. Okay? So it says, how much rain fell between 2:30 and 3:30? So this looks like it could be difficult, but it's really not. What I need you to think about is you're starting at a fourth, okay? And I hope I'm right. And you're going all the way up to a whole, okay? So what would I have to add to 1/4 to get to 1 whole? Well, if I changed my whole into fractions, that means I would have 4 fourths. 1/4 plus how many fourths gives me 4 fourths? 3 fourths. Good job, guys. So 1/4 plus 3 fourths gives me 4 fourths. It says, during which half-hour period did the rain fall most rapidly? So that's when you go back to your data and your graph, and you look for the longest line segment. A line segment is the little line that connects 2 points. So I'm looking, this one's kind of long, okay? But if I keep going on my graph, I notice that this one is much longer. So that means between 4:30 and 5, there was larger amounts of rain. Why is the line horizontal between 3:30 p.m. and 4:30 p.m.? So we're going to go to 3:30 and we're going to go up and we're going to look over to 4:30. Why is it the same? Why does it never change? That means no rain fell during this time, the rain increased at the same rate during this time, or the rain evaporated during this time. So what do you think happened? It's telling me this isn't right, but that would be my guess. I don't really see how it could be no rain fell. It could be that it evaporated. It doesn't give me enough information to really determine that, but it's okay if you get it wrong. It's going to move you on anyways, okay? So how much total rain had fallen by 3:30? I can see that 1 inch of rain between 2 all the way to 3:30, it gave me 1 whole inch of rain had fallen. Okay. It says how much total rain had fallen by 4 p.m. Well, that's an inch as well. How much rain had fallen by 4:30 p.m.? Well, that's an inch as well. There was 1 inch of total rainfall at 3:30 p.m., 4 p.m., and 4:30 p.m. Did any rain fall between 3:30 and 4:30 p.m.?
Let's look at this graph together. The half-hour period with the most rainfall was between 4:30 p.m. and 5 p.m. We can tell it had the most rainfall because this is the steepest line segment on the graph.
Okay. And when he says steepest, that's going back to the bicycle thing that I told you guys about. When you're riding your bike down this little line segment right here, yeah, it's kind of looks like it would be dangerous because it's so steep, but this would be way more dangerous because it's steeper. Okay. So when it asks you for, let's just say, the largest amount of something, you're looking for the steepest and longest line in your graph. I'm just going to keep going because we need to get to lesson 20. All right, so lesson 20, we're using the coordinate system to solve real-world problems.
Hey there.
All right, I'm going to jump ahead. It says the line graph below tracks the total tomato production for 1 tomato plant. The total tomato production is plotted at the end of each week. How many total pounds of tomatoes did this plant produce by the end of week 13? Okay, so we're starting at 0. And we're trying to figure out how many total pounds of tomatoes did it produce. Well, first I need to figure out, is my x-axis the pounds or is it weeks? So I need to go to my graph and I need to look. It says that my x-axis is going to be weeks and my y-axis is going to say total tomato production in pounds. They titled this graph total tomato production, okay? So that means if I am looking for pounds by the end of week 13, I got to 10. So that means that there were 10 pounds produced at the end of week 13. Okay. How many pounds of tomatoes did this plant produce from week 7 to week 11? Well, at week 7, we have 2 pounds. And then by the time we get to week 11, we're at 9 pounds. So 2 plus what number gives me 9? 7. Good job, guys. Which 1-week period showed the greatest change in tomato production? So that means that we are looking for our steepest line. Well, if you look closely, you can tell that the steepest line is right here, and it's from week 8 to week 9. So the greatest change was from the end of week 8 through week 9. Now it says which one showed the least amount of change. That's going to be the line that doesn't look steep, okay? It might even be a horizontal line. Remember when I said that the dog, Cammie, had a constant weight of 50 from weeks 24, 26, and 28? Do you see anything in this graph that could be constant? Let me give you a minute to look. And I can see that 11 and 12 are constant. It's just one straight line. Okay. What seemed to help produce the most tomatoes based on the line graph? Well, I want to go where my steepest line is because that's going to be where the most growth happened. That's right above our green water bucket that says weeks 8 through 10, water and fertilizer A. So that means water and fertilizer A helped produce the most tomatoes. All right, what didn't seem to help increase tomato production? And that's going to be fertilizer B. That's where our constant is. Sorry, guys, I'm trying to hurry. And I'm going to skip through the notes. We don't have notes, so we're not going to do them. Let's get to this last problem. All right, it says, how many pints of berries did Jacob sell on Saturday? Well, it says that Jacob sells berries at a fruit stand. When Jacob arrived at his fruit stand on Saturday, he had 57 pints of berries to sell. The graph shows the number of berries and pints that remained unsold at the end of the day. So he started with 57 pints, and then he ended up with 50 on Saturday. So that means that he sold 7 pints of berries. 57 take away 7 gives us our 50. All right. It says, during which 3-day period did Jacob sell the most pints of berries? Most means we're looking for our steepest line segment. So these are kind of hard to tell, but it looks like our steepest segment would be between Monday, Tuesday, and Wednesday. All right, it says Jacob sold the most fruit on Monday, Tuesday, and Wednesday. How many pints of berries were sold during these 3 days? Well, I'm going to start here. And that means that I started at 45. And by Monday, I was down to 35. So that means I sold 10 on Monday. Then I go from 35 to 25. That means I sold another 10. Then I go from 25 to 10. That means I sold 15. So I have to add my values together. 10 plus 10 is 20, and 20 plus 15 is 35. So Jacob sold 35 pints of berries on Monday, Tuesday, and Wednesday.
We can see that Jacob sold the most berries on Monday, Tuesday, and Wednesday because these are the 3 steepest consecutive line segments on the graph. He sold 10 pints on Monday, 10 pints on Tuesday, and 15 pints on Wednesday. 10 plus 10 plus 15 equals 35 pints. So Jacob sold 35 pints of berries on these 3 days. Awesome job today, Zoe.
All right. That is the final lesson of your 5th grade math year. So congratulations. We did finish on time. If we would have been in school, we definitely would have been done with this lesson by now. I know you guys would have rocked it. I really hate that we didn't get to experience that and finish that up together in person. If you have any questions or you need any help, you know to screenshot any question that you're stuck on and send it to me. If I'm not able to answer it right away, I promise you I check my phone all throughout the day. I will get to it and I will help you get the answer that you need to solve the question and move on. Remember, I told you if you would rather do 19 and 20 this week instead of waiting till next week, you will have to message me and ask me to move you up. That's perfectly fine. I don't mind. I might not be near my computer at the time. I'll just log into my phone and move you up as quick as possible so that you can get those done. If you want to wait, chill out, finish some makeup work. You might need to catch up for Miss Champagne. You might need to catch up for me in science. It doesn't really matter. You can take those days and chill out. You could probably finish all of this by Wednesday, okay? Have it done early. You could probably finish this all in one day. Some of you will do that because you love math, which is awesome because I love math too. Okay. There's going to be some fun things happening the last week of school, so be prepared. We're planning. We're doing our best to find something fun. We can't meet in person, and I hate that because I miss you guys so much. But keep an ear out. We're working on getting some fun things together to do virtually. So we're trying, and we miss you and we love you. And I hope that this video helped you on Zern somehow. Good luck, and I hope to hear from you guys soon. Bye.